Hello student, very good morning to all of you. I think or I hope you all are happy, healthy and fine at home. I think what what were we do you remember what were we discussing yesterday? I think we were discussing about the Claisen ester condensation reaction. What does it mean? What type of the starting material or the substrate used, as well as what kind of the base is used to carry out the Claisen ester condensation reaction, how many type of the reaction, condensation reaction, why it is called as a condensation reaction. So this type of the questions answer we already discussed in our previous lectures. Let's just recap the story of yesterday's lecture. In yesterday's lecture we have seen the Dikman cyclization. Remember, Dikman cyclization, the name itself suggests that cyclization means there is a formation of the cyclic type of the beta keto ester, and as we know that these are the synthetically very important one, because most of the organic compound present in the cyclic form, and therefore in these kind of the reactions are very or highly important as a synthetic point of view is concerned. So this type Dikman cyclization, or you can remember Dikman cyclization is nothing but as a intramolecular Claisen ester condensation reaction. Intramolecular, the word, remember, intramolecular means what? The reaction carry out, reaction takes place within the molecule, and whatever the requirement required for the reaction of that Claisen ester condensation, that everything whatever that are present in the same molecule, within the molecule, and that type of the reaction is called as a intramolecular Claisen ester condensation reaction. But Claisen ester condensation reaction, to remember, one is a simple Claisen ester condensation reaction, and second one is a crossed Claisen ester condensation reaction, and third one is a Dikman cyclization. And what is that Dikman cyclization? What type of the starting material to use, that we have seen when the two ester group are the part of the one and the same molecule, an intramolecular Claisen condensation takes place, giving 5, 6 or 7 membered cyclic beta keto ester. This is called as a Dikman cyclization, and this we have discussed with the help of, by taking as a suitable example. Now look at the blackboard over here. What is written over here? Perkin's reaction. Or at the beginning I already told you that in this chapter 4 famous reaction, named reaction we are going to learn. So far we have learned the two important reaction. One is aldol and second one is a Claisen. Aldol condensation reaction and the Claisen condensation reaction, and they are having as a similarity because both the reaction are proceeding via Carbinion, and that's why condensation reaction takes place, and therefore they are known as a nucleophilic. And as we know that there are two kind of the reactions are taking place. One is called as a nucleophilic addition reaction, whereas another one is known as a nucleophilic substitution reaction. So aldol condensation reaction, it is belonging to the nucleophilic addition reaction, and whereas that Claisen ester condensation reaction also the nucleophilic addition reaction. Over there two molecules get condensed together, and that's why, and the criteria for it, there must be a alpha hydrogen atom. In Claisen ester condensation there must be two alpha hydrogen atoms are present, then and then that undergoes as a condensation reaction. If only one alpha hydrogen atoms are present, that type of the compound, even though they containing as a ester group, do not undergoes Claisen ester condensation. And therefore remember, whether what is your first job to do, you have to recognize, you have to identify the molecule whether they are fulfilling the criteria of that Claisen ester condensation or not. That you have to identify, you have to recognize first, and then carry out the reaction. And now is a Perkin reaction. What type of the molecule starting material required for that this reaction, what is the specific reagent, specific base used here, what are the starting material is used here, and what will be the product formed here. So that type of the thing you must remember. As far as a Perkin reaction is concerned, it is known as a Perkin condensation reaction. Means here also two molecules get combined together, there is a formation of the because this reaction, let me tell you, this reaction proceeding through Carbanion, and therefore because when this reaction proceeding through Carbanion, there is a formation of the new carbon-carbon bond, and therefore these kind of the reaction are synthetically very, very important. And this Perkin reaction, Perkin is a scientist name. He what he did for this reaction, how he carry out the reaction, what type of the reaction condition he maintained, and what are the starting material, what is the reagent, or what we can call it as a base generally used, because for the formation of the Carbanion required as a base, and base, the function of base to form, to generate the Carbanion, and once the Carbanion is formed, and that Carbanion, if it is pick up the proton, that will result into as a formation of the neutral molecule. But when that attack to the carbon atom, or what we can call it as there is a formation of the carbon-carbon new bond, condensation reaction occur, and we are getting as a resulting product. Here he has taken as a aromatic aldehyde as a starting material, and that starting material, another one is a acetic anhydride, or the acid anhydride you can call it, but specifically Perkin has taken the compound is a acetic anhydride, and that acetic anhydride first treated with the sodium ethoxide or sodium acetate, and that sodium acetate, as we know that it is a strong base, it is abstracting the proton from the acetic anhydride, forming as a carbanion, and once that carbanion is formed, that carbanion is attacking on the carbonyl carbon of that benzaldehyde group, and further we are getting as a compound, and that compound further treated with hydrolysis, and then resulting compound is formed as a cinnamic acid. So in this way and we know that this cinnamic acid, one of the important compound as per as organic chemistry is concerned. It has some medicinal properties. It exhibits or it shows some medicinal properties, and therefore these reactions are very, very important as far as the organic point of view is concerned. Let us start. What do you mean by that? Perkin reaction, I already told you that how the reactions are taking place. So first, let me take as a starting material is a benzaldehyde. Everybody knows the structure of that benzaldehyde, C double bond OH. This is the structure of benzaldehyde. This is a compound of benzaldehyde that will be treated with acetic anhydride. Acetic anhydride, we can write ACTO, or we can write this one is like this CH3, C double bond O, then C double bond O, CH3. This group is particularly abbreviated, or what we can call it as AC is nothing but as a acetyl group. This AC is nothing but C double bond O, CH3 group. This is called as a acetyl group. There are two acetyl group, and therefore AC twice O clearly indicate, and then that will be treated with sodium ethoxide CH3, C double bond O, ONA plus. This is a sodium acetate. This one is called as a sodium acetate. Sodium acetate. This is the reagent used here, and which is a strong base. The function of that strong base which will abstract the proton, and the resulting compound we are getting over here. This one, let me draw the product first. CH double bond CH, then C double bond O, OH. The common name of this compound, look at the end. What type of the functional group is present? It is acidic one, and therefore the common name is this compound is known as a cinnamic acid. The cinnamic acid generally has a sharp melting point, which is solid in nature, 133 or 32 degrees centigrade. That is the melting point of that. That is fine white crystals are there. So this is called as a Perkin reaction. Now, how he got that Perkin reaction? Let us see the mechanism over here. And once you know the mechanism, then and then after that you can easily predict the product. As we know that mechanism is a language of organic chemistry. If you know the language, you can express your thoughts very effectively, or what we can call it as in terms of the organic chemistry mechanism. The definition of the mechanism I already told you, but let us see once again definition of the mechanism. A detailed study of sequence of steps which are involved in the conversion of reaction into product is known as mechanism of the reaction. Now let us begin with the mechanism. Let us see here, as we know that acetic anhydride, how it is acetic anhydride is obtained. This acetic anhydride, if you see the retrosynthetic, and that chapter is the next chapter that we will study after that. But here this acetic anhydride can be obtained from 2 moles of acetic acid. We know that this is 2 moles of acetic acid. Just heat under Al2O3 or at 200 degrees centigrade. There is a remole of water molecule, and that form as this type of the compound, which is known as acetic anhydride or acid. As we know that the general formula, do you know the general formula of acid? Yes. What is that? General formula of acid is RC double bond OH. This is the general for R, maybe as alkyl group or the aryl group, and then 2 mole of it heat it, you will get R C double bond O, then C double bond O, R dash. This is acetic acid anhydride. This is known as acid anhydride. Acid anhydride. This is one of the derivatives of the acid, you can call. There are the different derivatives of the acid. From that acid we can get as a ester, that is one of the derivative. Acid anhydride is a derivative. Acetyl chloride also as a derivative. Amide also as a derivative. So these are the different derivatives of that acid. You might be you already know that, but let us see the here what the mechanism we are writing over here. H, then C double bond O, C double bond O, then CS3. Look at the mechanism, observe the mechanism carefully. Then sodium acetate means this one, CS3, C double bond O minus will pick up the proton from here and form the carbanion. This will be the step number 2, because this mechanism involves, I think, 3 steps. Let's see there. And now in the first step, what is going to happen? Formation of the carbanion, CH2 minus charge over there, and then C double bond O, then C double bond O, CS3. Look at over there, right? And this carbanion you can show as a resonating structure, or as this one forming as a double bond, and the negative charge develop on that oxygen atom. CH2 double bond C, O minus, then O, C double bond O, CS3. Other part of the organic compound I am keeping as it is. What are the changes we are making? Because this resonating structure clearly indicate that there are the 2 ways to show the delocalized structure. That is the meaning of that double-headed arrow. Only that single arrow clearly indicate that react to give, and whatever this react to give, that is the meaning of this simple arrow. And then now let us look at as a step number 2 over here. Step number 2, what we do taken as this. Now take down this aldehyde benzaldehyde group here. Then I am putting C double bond OH, and I am writing hydrogen atom for the mechanism point of view in this way. And then now this one, CH2 double bond C, O minus, then O, C double bond O, and this CS3, right? What I have done over here, I am taken this compound as it is, and this benzaldehyde from here. Now what is going to happen? This negative charge forming as a double bond between this carbon atom and the oxygen atom. This double bond now attacking on this carbonyl group, and negative charge acquired by this oxygen atom, and we are going to get over here this one. Let's see here, carbonyl group, then CH, this H I am writing here, so O minus, and then this one CH2, then now C double bond O, C double bond O, and CS3, right? And now in the step number 3, what I am going to consider over there, in the step number 3, I am taking this compound as it is over here, and that will be written as it is like this here. Then CH O minus, and then here CH2 C double bond O, then O, C double bond O, and this one CS3. Now this, during the workup, this will pick up the proton from over here, H, suppose O, H, O, here is a hydrogen atom, positive charge over there, and this will pick up the proton from here, neutralizing. What you are going to get? You are going to get over here, this one, double bond, this benzene ring as it is, then CH, then here OH is coming, then here is a CH, 2, then C double bond O, then O, C double bond O, CH3. I am writing this compound as it is. And now next one, what is going to happen here? Now let us see this compound in the step number 4th one here, step number 4th. Let me write this compound as it is over here. In short, I am writing this phenyl group. Here is a pH, then rest of the thing CH, this OH. Now 1H I am writing from this CH2 from methylene is like this, then C double bond O, then O, C double bond O, this CH3, right? And now what is going to happen? Just after the heating, it easily lose as a water molecule H2O. There is a elimination of water molecule, this forming as a double bond over here, and this hydroxy OH get eliminated. What you are going to get here? pH. After that CH double bond CH, and then C double bond O, C double bond O, and this CH3, right? And now this is the compound we have got over here. And after that, in the next step, what is going to happen? Again hydrolysis easily carry out. Let us see this compound once again over here. CH double bond CH, C double bond O, then C double bond O, then CH3, right? And now after the hydrolysis, whatever here OH is remains there, that OH is going to attack on this carbonyl group, this revolving as it is, and there is a generation of acid from hydrolysis H2O, and you are going to get over there pH, CH double bond CH, then C double bond O, OH, and side product is a CH3, C double bond O, OH. The side product obtained during this reaction in a Perkin reaction, that is also as a very useful as far as this organic chemistry is concerned. This is a acetic acid. Acetic acid is a side product obtained, and this is known as a cinnamic acid. Cinnamic acid. So in this way we have seen how these Perkin reactions are taking place over there, and we got as a this type of the reaction, right? Understood this? What is, or write a notes on a Perkin reaction at that moment, at that time you have to mention, remember as a, what are the starting material, what is the reagent used over there. Now let me give you one more example over here, whether you are able to draw the able to predict the product or not. Let me check. Let us see over here now example, so that you can clear your doubts. Or here let's see. Now I am giving one of the example by considering starting material is a benzaldehyde, no doubt about it. Suppose we have this one benzaldehyde, as we know that C double bond OH, then what is the here CH3, then C, CH3, then O, and here hydrogen atom, then not this one, here C double bond O, then O, C double bond O, then C, here CH3, H I am writing over here, and CH3, and that will be treated with sodium acetate, which is a reagent used as O. There sodium acetate O, C double bond O, and CH3. Generally negative charge on the oxygen atom, and as we know that metal always carries as a positive charge. So what will be the product you are going to get over here? Is there formation of the cinnamic acid, because for this reaction it requires a 2 alpha hydrogen atom. but here only one alpha hydrogen atoms is present over here, and therefore it will produce the products are like this. Let us see as this one, benzene, then CH, OH, then this C, then you are going to get over here this CH3 and this CH3, then after that COOH, that is a group acid. You are going to get alpha beta hydroxy acid, you are going to get alpha beta hydroxy beta phenyl propanic acid. The IUPAC name of this compound, this is this one is alpha beta, the alpha position, so alpha dimethyl beta hydroxy beta phenyl 1 2 3 propanoic acid. This will be the what we can call it as a IUPAC name of this compound. And another side product is obtained over here, this one CH3, then CH3 C double bond OH. This one is again alpha methyl propanoic acid, that is a product is formed this one. So 1 2 3, or you can call it 2 methyl propanoic acid. This is a side product obtained during this reaction. So I think with this Perkin reaction proceed more readily when the aromatic aldehyde as a nucleophile atom or a nitro group in the nucleus. So in this way we have completed as a Perkin's condensation, or what we can call it as a Perkin reaction. Remember what do you mean by the Perkin reaction? At that moment you have to describe, or you have to give the reason what do you mean by the Perkin reaction. So after that we are going to learn regarding as a Carbanion in nucleophilic substitution reaction, right? That are the thing we are going to learn over here. This is about the Perkin reaction. Now one more point we are going to discuss here. What is that? That is a Carbanion in nucleophilic substitution. Carbanions in nucleophilic substitution, or what do you synthetic reagent, or we can call it as a synthetic reagents. So that is the point we are going to discuss over here. A new carbon-carbon bond can also be formed using Carbanion as a nucleophile. For example, suppose we have a starting compound here, negative charge, and then that Carbanion can attack on a alkyl halide, as we know that Rx, and what is going to happen? This negative charge can act this Carbanion. This is a Carbanion, and this species is known as alkyl halide, and the number of synthetic reagent we can prepare the new nucleophilic substitution alkylation. This is known as a nucleophilic substitution alkylation reaction takes place, and we are going to get over here this, then this is a new carbon-carbon bond is formed over there, and that's why synthetically it is very important in the organic chemistry. So here, as well as this Carbanion this carbanion can be attack on the carbonyl group C double bond over here like this one, and there will be a, suppose we have a, sorry, here R then X. This is a acyl halide we can call. This is acyl alkyl halide, not alkyl halide, that is the compound is known as a acyl halide, acyl halides, and therefore this is going to remove over there, and this type of the reaction is known as a nucleophilic substitution acylation. Nucleophilic substitution acylation. And nucleophilic substitution acylation, where you are going to get here R then C double bond O, that acyl group you can introduce over there, and this is nothing but as a new carbon-carbon bond is formed over there, and that's why synthetically it is very, very important. And in this way various alkyl and acyl group can be attached to the carbanion, and various compound which generate stable carbanion can be used as a nucleophiles. Such compounds are known as a synthetic reagent, and we will describe synthetic application of malonic ester and acetoacetic ester in this section, and show how complex molecule can be synthesized starting from the simpler molecules, that is a malonic ester diethyl malonate, the structure and their how it is applied, or what are the application of it, how we can use in the synthetic point of view. That is the first one we are going to learn as a malonic ester, their structure, how we can prepare that malonic ester starting from what, and there is a reactive methylene group, why it is called as a reactive methylene group, from where it is prepared. That synthetic application we will see in the next lecture. I think let us stop today here. Have a nice day. Thank you.